Hey everybody, welcome to Learn Tech Studios. Today we're going to be going over a circuit that we're going to construct. It's a light activated alarm. I'm going to go over the description of the circuit, and I'm going to explain this drawing to you about the circuit, and then we'll talk about the components, and then we'll actually put it together. First we're going to be starting off. This circuit is going to be built around a 741 operational amp. It's a little chip. It's an 8-pin chip actually. It has 8 pins, just like the 555 timer does. I don't know if you can see that really well, but let's see. Yeah, it's a 741 op amp is called, and essentially it's a comparator chip. It has a voltage comparator built in here, and it's an 8-pin chip, and we're going to show you how that's wired up in a little bit. The next item we have here is going to be the light dependent resistor, which is known as an LDR, and what that does, that operates by way of light. If it's in the dark, it changes state. So like if it's exposed to light, it usually changes its resistance, and the resistance in this device actually drops, and then when it's brought back into darkness, the resistance of it goes quite high. But it's a tiny device. It's only about this big. It's a little bitty thing. It has some little squiggly lines in it like that. You can see that, and that works by light. We'll show you how we're going to hook that into the circuit. And that particular device will be going to pin 3 of this op amp. It's one of the non-inverting inputs. It'll be going there, and then the other end will be going to through a current limiting resistor, and then on to the positive rail. My next item would be this solid state buzzer, and it's going to be, it looks like this. It's a little bitty thing. It gives off a good audible sound. It has polarity, so we have a positive and negative pin on the bottom, and that will be going from being fed from an NPN transistor here. This is the emitter, and it will connect. Just being the transistor works by when it receives a base pulse, it acts like a switch, so it connects the collector and emitter together, completing the circuit, causing the buzzer to fire. And that little transistor is this little guy here, a little bitty tiny thing like that. That's an NPN transistor, and that's what we'll be using to operate the buzzer. Also, we'll be using an LED light emitting diode. We will be using a 100 ohm current limiting resistor with that one. And this is the blue. I'm gonna use a blue one today. There's an anode and a cathode area on there. The flat surface being the cathode surface. That's the negative side. We'll show you how to hook that up in a moment. Then we will, and essentially this part of the circuit, when it receives a signal, it's going to, like I said, it's going to act like a switch. It's going to complete the circuit, allowing current to flow from positive to negative. The next item we have is a potentiometer. So we'll be using a 10K potentiometer today. It looks something like this. It's just a standard hot variable resistor that you manually control like that. That's what's going to be. That's what this symbol is here. Then we have some resistors, of course, some sort of resistors we're going to be using. There's going to be a 10K resistor coming off of pin 6, a 4.7 thousand ohm resistor going to be coming off. We'll be tapping that pin 6 and going to ground. We'll be using the potentiometer to help, which is going to be used to adjust the sensitivity of the LDR once it's in the circuit. We'll be able to make it tune it a little bit to make it react to light or darkness. It's not that many parts with this device, with this circuit, but it's very unique. So we'll get started in just a moment. Okay, I'm back. Okay, this is the breadboard. It's a prototyping board that I use. It has 3 potentiometers. That's what you see here. I installed these into this board and plug them directly into the breadboards to make it easy to access and to tap into the potentiometers. We have 3 on board. We have a 10K potentiometer, a 100K potentiometer, and a 500K potentiometer that I configured to be already tapped into the board, so it makes for easy construction. This breadboard allows you to put circuits together and test them, and then if it don't work, you can take it apart without soldering. So it's like a solderless breadboard. You don't need no solder, need no heat, no nothing. You just plug a device in and go. So we'll be using that with the circuit today. We'll be powering this circuit with a 4200 milliamp battery, 3.7 volt battery system. That'll be enough to power the circuit. It don't take a whole lot of that. Okay, next we're going to get started with actually constructing. So we're going to start off by plugging in one of the integrated circuits, which is the 741 operational amp. I'm going to plug that on into the board and get that out the way. And you know, when we plug something into the board, it's like a little valley right here. You plug your pins on either side of the valley, because the pins are the connecting pins run this way. They run like off to the sides of the pins themselves, and that's how we'll be actually connecting the components. Okay, now I'll move this up a little bit. We're going to construct this while we're looking at the board at the same time, hopefully. Let's see. Okay. Alright, so far we have this 741 operational amp plugged into the board, right? So now we're going to get the LDR and run it from pins 3. This is the LDR here, and this seems to be connected to pin 3. Going through a 100,000 ohm resistor to the positive rail. So we'll try to do that. This is going to be the positive rail here. This is going to be the negative rail that I'm going to be using. So I'm going to plug my LDR in, or light dependent resistor, into the board like so. We have that in there. Now we're going to run the 100,000 ohm resistor from that point, from one of the leads on the LDR. We're going to send that. So right now I got this pin running to one side of the LDR. LDR is in this hole and in this hole. So I'm running the resistor from the LDR through the resistor, and I'm running out to the positive rail by using a little jumper. And we just plug the little jumper in. So plug it into the board. There. Okay, so right now I have the one side of the LDR plugged in. That's this side of it here is going to the positive rail, and now I'm going to send it off to pin 3 by connecting a jumper wire from there to pin 3. And let me see if I can find one that fits. What do I got to make one? I'm going to just take a piece of connecting wire and go from the LDR to pin 3, which is here. Alright, that's in there, pretty neat. I'm going to try to keep it as neat as possible on the board so it don't get too confusing. Alright, so now we have the LDR. I'll bring you a little closer because it's a bit further away than I'm going to be. Let's see here, just a moment. Alright, then you can see that a little bit better. Okay, so I have the LDR going to pin 3, also going through the resistor here, this resistor right there, to ground. I mean to the positive rail, not ground. Okay, our next item is going to be running a wire from pin 2 to the potentiometer. We have a built-in potentiometer on the board, so we'll be using that. We're going to go, pin 2 is going to go to the wiper arm of the potentiometer. This potentiometer has 3 pins, like a middle and 2, a left side and a right side. So we want the wiper arm, which is the middle pin. So we're going to run a jumper from pin 2, which is here off the 741 to the wiper arm of the 10K potentiometer we'll be using. So that's connected right now, as you can see. See, that's going to the middle one right there. It's just off there. All right, next I'm going to connect the remaining on the wiper arm of this potentiometer. It shows here after this is the wiper arm, it goes to pin 2, we did that. So the remaining part of the resistors of the potentiometer goes to the positive rail and to a negative rail. So essentially it just lays across the power rails, and we're going to connect that now. So I'm going to take a jumper. I'm just going to run one from the one side to the negative, and then another one from the other side to the positive rail. And that's all that's required on that end. So right now this potentiometer is tapped into the positive rail, and the other end of the potentiometer is tapped to the negative rail, which is this blue one. Okay, and we have the light dependent resistor. It's going through 100,000 ohm resistor, and it's going straight to the positive rail, and the other side of it is going to pin 3 of the operational amp, or the non-inverting input of the operational amp. This is the non-inverting input, and this is the inverting input of the operational amp. Okay, our next item I want to try to connect here, we're going to try to connect the, let's see what would be best, the resistors. We have a 10K ohm resistor, and we have a 4.7 K ohm resistor. We're going to do that. We're going to connect the 10K to pin 6 and the 4.7 from the ground up to that resistor and connect them together. We're going to try that right now. So I'm going to get the 10K resistor, which is brown, black, orange. Should be in color. Find the right one. Okay. I gotta switch one resistor out for something. I just noticed something. I'm gonna switch this resistor out for the right one. There. That's a better one there. Okay. Okay, now I'm going to connect pin 6 to a 10,000 ohm resistor. This is 4, 5, 6, so pin 6 is here. I'm best way to do that. Should I stretch it across, or should I just tap it in and see what would work here? We want pin 6, so pin 6 is here. I'll try to just run it across. I don't know if that'll work really well. We can try, see if it'll work. Both ends to be connected. I believe that's got a connection there. But the base, the bottom of this resist is in pin 6, right there, pin 6. That's one of the connections. Then our other one is a 4.7 ohm resistor. It meets here at the tip of the 10K resistor, and we want to just put that just there. Trying to make is this connection, this junction right here. I'm making this junction right here. This is the 10K and the 4.7. I'm making this junction here so I can run it off to the transistor in a moment. But right now I'm running this 4.7 down to the negative rail. That's what I'm gonna do now. So I'm gonna take a wire and try to get the 4.7, this guy here, down to the negative rail. That's the negative rail. Now I just gotta get it plugged into the right socket. There. Alright, so we got the wire running from the 4.7 down to the negative rail off that resistor. Okay, next we're going to hook in our NPN transistor, and the labeling is you got your emitter, base, and collector, so that's EBC. So we'll be connecting. I'm just going to put that somewhere convenient right there for now, just to be able to make it easy for hookup. And as we said, we're going to run the point where these two resistors had met right here. That'd be there to the base of that transistor. I'm gonna see if I can do that with a jumper. I'm just gonna plug that there, and it should go to the base of this NPN transistor, like so. See, I really didn't want to use a lot of jumpers because they kind of make things kind of messy after a while. So let me try something here. So let me move something around. I'm gonna try to keep it neat without using jumpers. The jumpers seem to just make things a little bit more confusing than it is. So push that there. Now we have the wire running, as you can see, coming from the junction point of those two resistors to the base of that transistor there now, and that's connected. Now, as we see here, this junction that I was talking about is now connected to the base of this transistor. Now, this transistor collector part has to go down to the positive rail. It goes all the way down to the positive rail. So we're just going to run a line from the collector down to the positive rail. Let me see if we can just do that. I'll just put that in there and put that on the positive rail like that. Just put that there. So now that's connected. As you can see, that's going into the collector pin where the holes the collector's in, and it's running to the positive rail. The next thing I see on here is the emitter pin here getting a connection to the part of the buzzer, the positive piece of the buzzer. So I'm going to and the base of the buzzer is going. The base of the buzzer is going to a ground. The positive of the buzzer is getting a feed right off that emitter of the transistor. So we're going to connect that together. Let's see. So that's going to the negative. I'm going to put the one in the negative, one in the positive, and let me see if I can run a little piece of wire from the collector down to this side of the board. Let me see if I can get the wire here. It'll make for easy connection. Get that to stay. I can run this. I think I'm trying to run it right about here. Sometimes these wires don't stay nice and stiff the way they should, so you can push them into the board. That might be okay, maybe. Okay, now I'm going to hook this positive pin here, this positive piece right here, the end that's positive right there. It's got to go to that pin right off the emitter into the negative, like I did there. So now that's connected. So now what we have essentially is the transistor connected to the buzzer, piezo buzzer, which is connected to the ground. There is an LED hookup that I have on here, which is has a current limiting resistor involved that is going to just tap. It's going to use some of the voltage from this buzzer to fire. When the buzzer fires, it lights up as well. I'm going to try to put that in place. Let's see if I can. Okay. Put the LED inside the circuit, which would be the anode side facing the transistor, it looks like. So, connector in of that. I'm just going to put, let me see what's the best way to go here. That's the negative side. So, got the anode side going there. And I'm going to attach a jumper from the emitter. If I can find an empty spot. Let's see. It's the emitter. It's the emitter there. So let's see if I can get that in there. Okay, so now we have the anode going to the emitter of the transistor. Now I just got to get the cathode to go through the resistor onto the negative rail. And I'm going to do that. Use a jumper, it looks like. I'm gonna try to see if I can patch it in though. Cathode in, run it to there, and then run it straight to the negative side of that rail, which is here. So far we have the LED, and it's current limiting resistor plugged in. As you can see there, plugged in there, and that would be on the paper here. So that's the cathode running through the resistor to the negative pin, and the anode going without a resistor straight to the emitter pin. So that's in there, I believe. I'm looking this circuit over. I'm trying to see if there's anything else we're missing. Something tells me that there is. Okay, so pins 2 should be going to the wiper arm of the potentiometer, which it is. That's going to there to 2. And the other side of the wiper arm, which is here and here, are going to the rails. One goes to positive, one goes to negative. It don't matter which side. And we have the light dependent resistor going from pins 3, going through a resistor to the positive potential. So that's going from pins 3, which is here, going through a resistor, skipping over to the positive potential here. Okay. So it looks like we may have it put together. Now it comes time for adjusting. I have like I said, I have a built-in potentiometer there, and that's what these wires running from going to the board. That's what's connected to the circuit. I'm going to bring you out a little bit. There. Now I'm going to try to power it and see where we are so far. Like I said, I'm going to use the little battery pack. I'm going to try to power the circuit. Just grab some power leads. One to go in the ground. Let it go to the back of this. One go into the positive side. And if it works, we should be able to hear something or see something. Let's see in a second. Okay, I'm gonna plug in some power. Right now I have nothing going on, so let's see if I adjust what happens. Nothing so far, so I'm gonna disconnect that. Right. What are we missing? Let's take a look. Okay, so now we have to look over the wiring to find out where's the missing link. Let's see here, pin 7 needs to have a positive. I don't think I hooked up pin 7 yet. Let's see. Sometimes you have to look over your work to find it. But like pin 7 does not have any connection, and that may be the only problem we have. So I just need a jumper wire to put in place of that. Grab that. So I'm gonna take a jumper wire, go to pin 7. Let's try the circuit again, see if it'll work. Nothing there, nothing there. So, that's okay. After we got pin 7 in, we got pin 7, so we know that's connected. The collector piece here should be going to the positive rail. Let's verify that. That's the collector, and it's going to the positive rail. Let's see. Pins 2. It's going to the wiper arm here. schematic again. So as we see, we have the collector hooked up, which is going here. The emitter is hooked up, but let's see, is it getting it right? It's going to positive. This one goes to pin 6, which is here, and pin 7 goes all the way to positive, which is here, and pins 3. Okay, let me get my voltage tester, and I will be right back. Okay, we're back. I was able to narrow the situation down. A couple broken leads were in one of the wires. I had to use a logic probe to find it. But I found it, and I think I got the circuit working, so we're going to commence where we left off. So right now I'm going to power the system and make any adjustments. Let's see. Now the way this ought to work is so when you pass over the LDR, the system cuts off, and because the LDR resistance rises so high, when you move your hand away, or when it's dark, like when it's dark, the sound a cut off. Whenever there's light, I can't make it dark, but okay, now I make it dark. But whenever there's light exposed to the LDR, the alarm would sound. Essentially, this is the circuit I was trying to demonstrate. So it works by way of letting you know if an area, let's say if you have this in a cabinetry, and someone opens the cabinet, the light gets in, the alarm will sound. It'll let you, like a little alerter, or something like that. That's the basis of this circuit. So the comparator in here, this thing does like a flip-flop almost. According to the resistance of this LDR, it'll change the state of the non-inverting input and send an output to pin 6, that signal will go always to the base of the transistor, which will close the transistor like a switch, and that's what, and it'll make the circuit for the buzzer complete, which would be the positive and negative side, which it needs to ring. Also with the LED as well. The LED just paralleling the buzzer and using a current limiting resistor. Alright, so that's all I have for today. I hope this wasn't too confusing. But if you have something you want to see in me demonstrate or to configure, just leave a message in the comments and stuff. And as always, try to subscribe or leave a like or a comment. I get a lot from the comments in my email, so leave some comments, give me an idea of what you want to see. But until next time, have a good day. Thanks. Bye.